All right, the final added section, because I added this in the middle of class today, for the review, cubic regressions. This has, I think, been the one thing that people have been real scared of. Don't forget that I did give you, actually I'm going to go to my webpage and show you right now. I did give you directions for the regression. If you go to my webpage, click on Documents, go to Precal, and it was a worksheet, so we'll go to Worksheets, open that up, and the regression directions right here. Regression directions, download that, and then just make sure that you look at the correct directions. I will give you a copy of this for the test. It'll be TI 8384 on one side, and if you're using an 89, that's on the back of it. But just know that after this test, I'm going to expect you to be able to do the regressions on your own without the directions. Also, as far as the test is concerned, it takes you a long time to read the directions and punch it in little by little. You're going to end up spending 15 or 20 minutes on one problem if you aren't familiar with it. So make sure that you know how to do the regression. So, all that said, punching in the regression on the TI-89. I'm going to show you how to do this real quick. So here is my TI-89. I'll start by hitting the Apps button, and you can't see the buttons, but hit the Apps button, scroll around until you get to Data Matrix Editor, select Enter, and I've gotten to where I just open up my current one. So I'll open up the current Data Matrix Editor, and then I will actually go in, and I'm going to clear out all of this stuff, because this is something from a previous problem. So clear, 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 go over, clear all this, and then I'm going to re-enter my information. So my chart right there, I'm going to have to enter that. Okay, so punch that in, and my X's are 2, 4, 6, 8, 10, and 12. And then I will go over and I will punch in my Y coordinates, which are 48, 14, 35, 206, 627, and 1362. And I punch it in. And then all I wanted you to do, if you look at the problem, all I want you to do is to find the cubic regression. I didn't ask you to do a scatter plot or anything like that. So I'm going to go straight to the regression, and to do that, you select F5. That's the calc, so F5. And then under this toolbar, you want to pull that open, hit the arrow to the right button, and you go down until you find cubic regression, which for me is number 3. So I'll select cubic regression. Then I have to tell this thing that X1, that column 1 is my X's. So I have to toggle the alpha button. You want to hit C1, column 1 for the X's, alpha C2 for the Y's. And then I like to store my regression equation in for Y1 because the 89 does that very nice. So I select my cubic regression, column 1 for my X's, column 2 for my Y's, store for that. Then I will just hit enter. It'll think for a second, and it will pop up a regression. So here's my regression. I'm going to take a screenshot of that. So here's my regression equation, and we will write that down. Okay, so writing this down, it's ax cubed, and a is 1.8, so 1.8 x cubed plus b, which is negative 14 point, and I'll round that to 5, so negative 14.5 x squared. C is 16.3, so plus cx, 16.3x, and d is 59.3. So there's my function, and use it to estimate f of 3. So my function, I guess I should say that's f of x, or whatever, I'll say y. So my function at 3, f of 3, is going to be approximately 1.8 times, and I'll just plug in 3 for all the x's, minus 14.5 times 3 squared, plus 16.3 times 3, plus 59.3. And I would encourage you to write that down, because if you type something wrong in the calculator, but I see what you meant to do, I can give you a lot of points for that. If all you do is write down an answer, it's hard for me to give you partial credit. So always show as much work as you can. So I'm going to punch that in the calculator. Okay, and I got 26.3 when I plugged 3 into the equation, which makes a little bit of sense, because at 2 I was at 48, and at 4 I was at 14. So at 3, 26.3 makes a little bit of sense. You also could, on the calculator, since I stored my equation for y1 if I go to my y equals screen, you can see there's my regression, and it stores it to a lot more decimals. What I could do is simply say, okay, well, tell me what is y1 of 3, and you'll get a much more accurate answer. I would accept either one of them. So if you wanted to say 28.063, because that's pretty darn tootin' accurate, I would be okay with that. So, or 28 point, what did I say? 063. Or 28.063 if you store the equation. So I would accept either one. And I'm going to come back through right now, and I'm going to do this exact same problem again on a TI-84 for those of you who are on an 84. So 89s, just kind of skip forward a little bit. I'll put a note in the video where to skip, I don't know, whatever. So 84s, here we go, it's your turn. All right, 84s. The way we do this is we hit the stat button, which the stat button is right there next to xt theta n. So I'll hit stat. It opens up this menu, and we want to edit a stat. And I first have to clear all this out. So I'm going to clear. Oh man, how do I clear this? Delete. There it is. So I'm going to hit the delete button until all of those are gone. So I'm hitting the delete button, clear all those out. Hey, an announcement. This is exciting. Okay, and now I'm going to enter all that information. So 2, 4, 6, 8, 10, 12, and then I need to do the other ones, 48, 14, 35, 206, 627, 1362. And now that I've done that, we hit second quit. So second quit right there at the top. So I'm going to second quit back to my main screen, and I need to compute the regression. So the way I'm going to compute the regression is I go back to that same stat button, calc, and we want to find the cubic correct, which for the 84s is the option number 6. I'm going to cubic regression of that information I just punched in. I'll hit enter, and here's what I get. Notice it is all of the exact same numbers we just got when we did this on the TI-89, if you happen to watch the TI-89 section. So this is what we get for the cubic regression. And we write it down, so it's a times x cubed, and a is 1.8, b is negative 14.5 x squared, c is 16.3 times x, and plus d, which is 59.3, and then we will plug in 3 for that equation. So we plug in 3 because I asked you to use your answer to estimate f of 3, and when you plug in 3, you get a value of about 26.3. So we would say that f of 3 is approximately 26.3. And that would be your estimate for f3, which makes sense because 3 is between 2 and 4, and 26.3 is between 48 and 14. So that makes a little bit of sense. All right, so let's see. Moving on to the last problem. Find all this stuff, starting with each root and its multiplicity. Well, roots are whatever makes those factors 0. So I'll do 1 minus x equals 0, and if I plug in 1 for x, I get 0, and the multiplicity is 1 because it's to the first power. X equals x minus 2. If I plug in 2, that gives me 0, and that is to the second power, so my multiplicity is 2. And negative 1 makes that last one 0, and that will be with multiplicity 3. So there are my roots. The x-intercept. X-intercept. I don't know why I wrote that, because we just did the x-intercept. I was thinking we need to find x and y intercepts. Okay, x-intercepts, that is the same thing as part A. Find each root, that is the x-intercept. So we really don't need to worry about that, because B and A are the same. So let's skip to C. I'm so stupid. I can't believe I did that. That's embarrassing. Okay, y-intercepts. Y-intercepts, you plug in 0 for x. So my y-intercept is going to be y equals 1 minus 0 times 0 minus 2 squared times 0 plus 1 cubed, which ends up being 1. Negative 2 squared is 4. 0 plus 1 is 1, and cubed is still 1, so you have a y-intercept of 4. So there's my y-intercept. Describe end behavior using limits. And in behavior, what we have to do is we look at the x terms in each parentheses, and we have to kind of expand this out. If you remember the in behavior problem we did earlier, everything was already multiplied, so we looked at degree and leading coefficient. I still need to find degree and leading coefficient. And to do that, I see negative x, I see an x squared, and I see an x cubed. And if I were to only isolate that part of it out, because that's what's important, so I have, let's see, negative x, and then I have an x squared, and then I have an x cubed. Let's see, that would be, that's 6 x's, x to the first, x squared, and x cubed, so that's x to the 6th, and it is a negative leading coefficient, which means both ends are going to be going down. Negative leading coefficient with an even degree, both ends are going down. So in terms of limits, that would be the limit as x approaches. If I go to the left, that will be negative infinity. And as I go to the left, my function's going down. So my function approaches negative infinity. And my right end, limit as x approaches infinity of f of x is infinity. And then finally we get to sketch this graph, and this is going to be the end of this review. Where's my straight line tool? Here it is. Okay, and I will start by graphing my x-intercepts, which were 1, 2, and negative 1. So I have negative 1, 1, and 2. Those were my x-intercepts. And then if you remember, if you have an even multiplicity, you only touch the x-axis. If you have an odd multiplicity, you cross. So I'm going to cross, whoops, forgot the R, at those two, and I'm going to touch at x equals 2. My end behavior, I'm going to start down here. So I know I'm going to start down here. I need to hit my y-intercept, which was 4, so I need to go up to 4 and make sure I hit a y-intercept of 4. And let's see, I will cross at negative 1, so I'm going to come up, I'm going to cross, hit my y-intercept, and then I need to hit 1.
Julia Casino, please come to the front desk.
Hey, I think that was my mom. That's crazy. So I'm going to hit 1, and I will cross at 1. And then I'm going to have to come back and hit 2, but I only touch at 2. So I'm going to hit 2 and then come back down. I kind of missed that point. There we go. Come back down. And that's what this graph is going to look like. And that's a good enough graph for us right now. When you get into calculus, you're going to learn some techniques to make it a lot more accurate. But for now, this is good enough. So there we go. Those are all of the parts of the review. Hope this helps.